and for the introduction. I hope everybody hears me clearly, and if not, please let us know again. Can I have next slides then, please? Okay, thank you very much. This works. Right, these are the issues to be covered. And let's move to the next one. You've seen this one, I think. Yeah, I thought it would be wise to add a short disclaimer, because this meeting has grown much bigger than I expected beforehand. So what I've done is to put as many references as possible on the slides. There's much more information than I can tell now in this hour. So if the presentation can be put somewhere on the internet afterwards, you can follow all the references to see more information. And what is important, it's not my own research I present here. So if the questions get too complicated, I will have to redirect you to the original researchers. Yes, next, please. Yeah, just a few words before I really start about the organization I work for. It's the Netherlands Labour Authority, maybe better known as Labour Inspection. Our task is to enforce fair, safe and healthy work, as we call it. We have about 400 occupational safety and health inspectors to do that by means of inspections and also other interventions like, for example, communication, developing tools for companies, etc. Next, please. Myself, I work at the Center of Expertise. As Rudolf just told you, it's a center of about 70 specialist consultants that work for the inspection, 8 of which are occupational hygienists. Myself, I'm one of the 8. What we do is, as I just said, not our own research, mostly, but what we do is to collect and translate scientific knowledge and make it applicable for the organization. We are consultants for the inspectors and for managers in the labor inspectorates. We contribute to all kinds of activities. We make instructions for inspectors. We contribute to the prioritization that the inspection does every couple of years. And we maintain an online knowledge base for internal use. Next, please. Just a few words on, well, and a few figures that are a little bit more general, on the general level. These figures are based on, well, work of our own National Research Institute, RIVM, but also on IOM from the UK and on WHO. Well, substances has been a major focus for our inspection for, well, about 20 years, I think. What we know about our country is that about 3,500 premature deaths every year occur as a result of exposure to substances. A lot of healthy life years lost, DALYs. And from literature we know that, well, very roughly about 5 to 10% of cancer cases can be attributed to work exposure. And if you please move on, then you'll get some more text on this slide. Thank you. Here's just, oh, yes, thank you. Just a few factors that we know that contribute relatively much to the burden of disease, the burden of occupational disease, like welding fume, diesel engine exhaust, silicon wood dust, and isocyanates. About diesel engine exhaust, we have quite some data on the population at risk also. It's, well, the 900,000 that is stated here, it's a maximum. It's the workers that have at least some exposure to diesel engine exhaust. Occurs in many sectors of industry. For aircraft engine emissions, it's less well known. The 100,000 stated here for the Netherlands is a maximum as well. And, well, we have about 25 airports in total in Holland. 6 are the bigger ones. And well, the most well-known Schiphol Airport, Amsterdam, it's by far the biggest one. Next slide, please. And Schiphol Airport is also where this story starts, because for us it started back in December 2021 when a television documentary was broadcasted about Schiphol Airport, Amsterdam, and in this broadcast a number of workers expressed concern about exposure to aircraft engine emissions. What you see here at the right, that's just a picture from this television documentary, and there was a worker interviewed, and he says, well, that aircraft over there has been blowing into my face for 2 minutes now. And he was very worried, also stated that a number of colleagues have died of cancer as well, and so on and so on. Workers were very worried, and also at the same time a formal complaint was issued by the trade union, a large trade union, to the inspection. And then we had to start investigations in this issue. And in fact, up to that moment, 4 years ago, exposure to aircraft emissions had not been given much attention so far. And, well, what we know about diesel engine emissions is that it's only recently actually more and more electric equipment entered the market. So diesel engine emissions has been given more and more attention over the last 5 years as well. Much more than before. And for aircraft engine emissions, well, the issue is even more complex. So that's I think, one of the reasons why it hasn't been given much attention so far until 4 years ago. Next, please. Okay, because the trade union issued a formal complaint at the labor inspection, we had to start investigations on the issue. And in fact, 2 of our inspectors worked practically full-time on the issue since then, for 2 or 3 years. There's a lot of research being done by the inspection on the situation. Well, here's just an illustration of what happens. Most of you will have seen that flying, going on holiday or other travels. In fact, at the what we call the ramp or the apron, where the planes arrive and leave again, there's a lot of activity going on also. There's loading, unloading, there's refueling, towing, power supply to the airport. All kinds of checkups are going on. So there's quite a lot of workers around airplanes arriving and leaving. And it's also quite a complex exposure situation, because it's not only aircraft engine emissions that workers have to deal with. It's only diesel engine emissions, because, well, there's quite a lot of different diesel equipment being used. And in addition, there's also, at least at Schiphol Airport, there are emissions from the surrounding motorways that are, well, reaching the airport as well. So that's quite complicated when you're trying to do exposure research in this situation. And then in addition, also organizational, it's rather complicated, because there are many contractors and subcontractors working at the airport. So for an inspection, it's not always clear from the beginning who to address when you start interventions on this issue. Okay, next, please. Then let's start looking into, well, what's known about aircraft engine emissions. Most of you may know that diesel engine emissions have been classified as a Group 1 human carcinogen back in 2012 by IARC, and in my country some years earlier already. So then it's also clear what to do as an employer, because you may know that carcinogen regulations put the strain on employers to prevent exposure as much as possible, or minimize exposure as much as possible. Well, aircraft engine emission, on the other hand, focusing on the standard kerosene powered engines. Here's good to know that in fact we are dealing with two kinds of engines here. There's the main engines of the airplane, and there's also a smaller engine in the tail of an airplane, mostly called auxiliary power unit, and the APU. And the APU takes care of power supply inside the airplane until the power supply from the airport is available. Well, aircraft engine emissions. There's no IARC evaluation, there's no national evaluation, so from the start it was not as clear as for diesel engine emissions what to do. Should the employer prevent or minimize exposure as well in these cases? Well, that's why, next slide please. That's why we as an inspection and as a center of expertise of the inspection started a short preliminary literature survey ourselves. Here's just two interesting articles. I think these have been the most interesting we have found in that phase. Maciel 2014 has a lot of information on the composition of aircraft engine emissions. And the Benson article 2021 has both quite a lot of information on the composition, but also some results of early toxicological studies with aircraft engine emissions. And I will tell you a little bit more about that in coming slides. Next, please. Okay, actually, it's more or less comparable with diesel engine emissions when we talk about aircraft engine emissions. It's like diesel, a mixture of gases, vapors, and particles. Part of the substances in these are carcinogenic, both in the gases, vapor, and particle phase. And well, there's just some examples here mentioned between brackets. Focus on particles, we see that there's quite a large fraction of ultrafine particles in aircraft engine emissions, smaller than 100 nanometers. And even compared to diesel engine emissions, a much larger fraction of the particles are even very small, UFP, smaller than 20 nanometers. So that's the difference between AEE and diesel engine emissions. Next, please. Okay, talking about ultrafine particles, I thought it would be wise to include a small intermezzo, especially on the UFP issue, because obviously, UFP is only a general term indicating the size of the particles, and the origin and the chemistry of the particles may be very variable. That may be, well, traffic emissions, maybe even sea salt, especially in the Netherlands and in the West. We have predominantly western winds and the North Sea in the West. So in the west of our country, you will see that part of the UFP measured in outdoor air will be sea salt. Another example is wood burning, especially in winter, of course. So knowing that, it's not always the most useful measure to, when you do exposure research to measure only UFP, the ultrafine particles, unless you know from well, a smart measuring design, from the location of your measurements, that the largest part of the ultrafine particles you will measure can only be coming from the aircraft. Next, please. A little more on UFP toxicology. In fact, well, starting in the 90s, the last century, I think there have been quite a number of studies focusing on nanoparticles. The nanoparticle toxicology was really an emerging field of research in the 90s. And in the OSH field, we talk about nanoparticles when we're talking about particles smaller than 100 nanometers, and in the environmental field we say ultrafine particles, but in fact it's the same fraction of particles. I've just put here some names of well-known authors in the field. You may look that up. They've written quite a number of interesting reviews on the issue in the 90s and early zeros. Next, please. There's some more information on this slide. Some highlights from these studies. Well, obviously the particles are very small, and after uptake in the body, there's a wide distribution to be seen in the whole body, and also because of the small size, they have a very large surface area, giving rise to the primary effect of oxidative stress in the body, leading in turn to inflammation responses, and then in turn to all kinds of cardiovascular effects and airway effects. What is less clear is whether there's also a more general carcinogenic effect of ultrafine particles, irrespective of the chemistry. But of course, when we talk about diesel engine emissions and maybe also aircraft engine emissions, that's more relevant to this specific type of particles. Next, please. Anyway, we needed some more information on the issue. We were able to do very small. You're going backwards now. Sorry. Yes, thank you. We asked the research institute RIVM in Holland to perform a more elaborate study for us. They have studied literature more widely than we were able ourselves. They found 11 useful reviews. They found 142 individual components in aircraft engine emissions, but of course, by far the major emissions by volume were carbon dioxide, water, and NOx. Nevertheless, 21 class 1 carcinogenic substances could be found in aircraft engine emissions, and including the class 2 carcinogenic substances, it was 44 substances, but in very small percentages. These 21 together sum up to less than 1% of the total volume of the aircraft emissions, or volume or weight. Next, please. Well, in the next slide, you'll read a little bit more on what we know about health effects of aircraft engine emissions. First, one step back to the diesel engine emissions. We know that these give an increased risk of lung and bladder cancer, heart disease, airway disease, and when at short-term exposure, also some more acute effects like airway and eye irritations. Next, please. I just mentioned the Benson 2021 study, which is quite interesting. What they did was also evaluating the literature, but in addition to that, they've performed some own in vitro studies using aircraft engine emissions on cell lines, and what they saw was that gave, well, more or less similar effects than diesel engine emissions, which is, well, one first indication that also aircraft engine emissions might have carcinogenic properties. But research is relatively scarce on our aircraft engine emissions and still needs to be confirmed. Well, having said that, one further, please. What is interesting to know is that 2 follow-up studies will be done in my country. In fact, one study is running already. The Dutch Health Council has been asked to evaluate the carcinogenicity of aircraft engine emissions, but that's based solely on literature data that are still available, and their draft report is expected in second quarter 2026. Will be in English, I think, so interesting to track that. And in addition to that, the RIVM has been asked by our Ministry of Social Affairs to start additional toxicological studies, and they are at the moment in the phase of preparing a research proposal together with a number of partners. One of the things they are planning to do is to use markers of mutagenicity in blood cells and cheek mucous membrane cells, and those cells are taken then from workers working at the airports and from workers as control groups. And will be a cross-sectional study. Will probably start next year and will probably also take a couple of years to be finalized, but it promises to be an interesting study, I think. Okay, then we can move on to the next slide, and then we can move on to exposure. What do we know about exposure to aircraft emissions at airports? I'd like to tell you a little bit about two studies that have been done in my country. The first one has been done by TNO in 2021. They did not personal sampling, but they used a measuring device mounted on a car, and they drove a large number of tracks along the airport and measuring various particle fractions. Well, again, they confirmed that aircraft engine emissions have a high fraction of ultrafine particles, and also was confirmed again that it remains a challenge to distinguish between the various sources of particles, aircraft engines, diesel engine emissions, but also the other emissions coming from highways around the airport. Well, nevertheless, some highlights from this study on the ramps, on the parking spaces, so to say, where the airplanes arrive and leave. Average UFP concentrations of 100,000 to 200,000 particles per square centimeter, cubic centimeter were measured, and peaks even over 2 million particles while airplanes arrive and leave. And for comparison, it's good to know that background levels were also measured, were lower than 10,000 particles, and we know that in non-disturbed areas it's even lower. It's mostly less than 5,000 particles. So the exposure is clearly elevated compared to background. Next, please. On the next slide, you will see, just to illustrate an example of one of the very many figures that can be found in the report. I've put the link to the report on the slide you just saw, so you can check yourself. What they did was mainly to try to identify hotspots of exposure, indicated by colors here. So the dark blue and light blue colors are the lowest in concentrations, and the dark red the highest. To give you just one indication, green is about 100,000 particles per square cubic centimeter, and light red is over 1 million already. So that was quite an interesting study to get a first impression of potential exposure. But then, next slide, please. Follow-up study was even more interesting, I think, because in that study, personal exposure measurements were carried out by University of Utrecht in cooperation with NCAL, which is the National Center of Expertise on Occupational Lung Disease in Holland. This study has been presented at the IOA 24 as well, and also at the EPICO 25 2 months ago in Utrecht by Remco Huba, so you can, well, also find these online, I think, these presentations. Well, few highlights from their study. If you can move on, click further. Then we see just a few highlights. Concluded also that, well, comparable to diesel engine emission, elementary carbon is a good marker of exposure, and ultrafine particles are a good marker in any case as compared to, for example, inhalable dust or metal concentrations, which appeared not to be very good markers of aircraft engine emissions. Well, specific functions on the airport had quite high exposure, average particle numbers of 100,000 and more. I'll tell you a little bit more later on. Peaks again, higher than 1 million particles. Again, it remained a challenge to distinguish between the origins of the particles measured. And of course, there's not yet an occupational exposure limit for aircraft exposure, or for aircraft emissions, or for ultrafine particles. But what you see, the exposure is clearly elevated, or strongly elevated compared to background again. And what's also interesting to tell you maybe is that the Dutch Health Council has been asked to develop an exposure limit for ultrafine particles. And I think next year, 26, they will come up with a draft report on that. In addition, well, when we have still some time at the end of the presentation, I can tell you a little bit more about the provisional exposure limit that exists for nanoparticles, which might be used in this case as well. They've been developed some years ago already. Next, please. Just to add a little bit to this, don't try to read this when you're not Dutch or Flemish. I have not translated it, just to show once more that it's not my own work. It's University Utrecht NCAL work still. I wanted to highlight just 2 or 3 messages from this slide. It's result of ultrafine particle measurements again, particle count. One main message is that when you compare the different function groups at the airport, the difference in average exposure may be a factor of 9, so it's quite high. And among the relatively high exposed groups are workers that work around passenger planes arriving and leaving, workers that work as pushback truck drivers, but also employees of general building contractors that work at the airport to make all kinds of reconstructions. Right, so far for exposure. Now let's move on to the most interesting part, I think, which is control measures. What can we do about this? As most of you may know, that when we deal with carcinogens, well, then based on the EU CMR directive, employers are obliged to try to substitute when technically feasible. And if not technically feasible, employers should aim at minimizing exposure as much as possible by taking all measures that are technically feasible. And only after that, exposure assessment comes into the picture. This also means that we expect from employers, and also as an inspector, we expect that from employers that they actively monitor state of art in relation to control measures and control options. Next, please. Okay, obviously, first question always is, does exposure occur? Which is not true for every airport worker. If you compare the left photo with the right photo at the left, there will not be very significant exposure, and at the right situation there is. Well then, in the hierarchy of control options, of course, substitution also always is the first option to consider. Next slide, please. But in case of airplanes, it's still a little complicated. At the right-hand picture, you'll see a short news item of a few years ago telling you that the first electric airplane was arriving at Schiphol Airport, but as you can see, it's still a little small. I think, well, substitution in this case will not be a really feasible option for many, many years to come. So then, moving on to the next slide. There's more to achieve in the minimization of exposure field. Here's just a number of categories of measures. There's much more to tell about this as well, but I'll keep it a little short. Anyway, Schiphol Airport, after inspections by the inspectorate, has established a dedicated team working on options for control measures. And they have in fact made quite extensive plans working towards the year 2030, stepwise, trying to substitute diesel-powered engines, equipment, but also taking other measures in order to try and reduce exposure to aircraft engine emissions. And of course, first focusing on the most highly exposed functions, most highly exposed areas on the airport. Well, few control options just mentioned here. One option is to try to reduce the use of the main aircraft engines when airplanes arrive and leave. One of the options is emission-free pushbacks by using emission-free electric-powered pushback trucks, and also emission-free taxiing away from the apron to the starting positions by electric tow trucks. And so-called tug release points here mentioned here, those are the places where the airplane changes to and from the electric tow truck and to and from the own main engine. And it's tried to, well, position these tug release points farther away from the worker. Well, in fact, there are many other more organizational and operational measures trying to consider in connection more related to adapted routing and trying to increase the distance between worker and aircraft. And a third option, which is also quite important, is to try to reuse the additional small tail engine use that's, as I just told you, used for power supply in the aircraft. And there are two options here. There's a fixed power supply from the airport buildings, and at Schiphol Airport they're quite actively now in installing more and more points of fixed power from the airport buildings, and at more and more well, parking places for the airplanes. But another option is to use the large battery packs as a power unit, and that's what you see in the picture below. That's in fact a very large battery that is used for power supply inside the airplane. Okay, next please. On the next slide you'll see just an example of an electric tow truck for taxiing. Well, this is just an example. There are many more. In fact, there are dozens and dozens of different vehicles and machines, diesel powered, used at airports, and that of course is complicating substitution. And for every variant, for every vehicle, an electric alternative should be developed. But I have to say that Schiphol Airport is quite active, and also the KLM organization is quite active in trying to substitute all this equipment. Nevertheless, there's well, quite some challenges in achieving all this. And on the next slide, I'll put some of these challenges, which is the last of my main story. Well, of course, there's the point of technical feasibility to substitute diesel-powered engines, diesel-powered tow trucks for planes by electric tow trucks. They're available for the smaller airplanes already, but are not yet available on the market for the very large airplanes, the 747s, the wide-body airplanes. So that's not yet possible, and the tow trucks used for those are still diesel-powered. And then there are also large numbers needed when you need to substitute not only at Schiphol Airport but also at other airports in Holland that are starting to work on the issue as well now. Quite large numbers are needed, and the periods of delivery can be quite long, can be up to some years even sometimes. And then there's another issue of the impact of adapted routing on operational procedures. For example, the impact on collision risks need to be evaluated, and in fact, any change of operating procedures, any change of routing of airplanes need to be approved by a number of institutes, so that takes quite some time to arrange that. Then there's just another quite simple, bottleneck, that is the availability of contractors and availability of workforce at contractors to make the necessary changes to the airport. At least in my country, there's a shortage of workforce in construction industry. It's quite hard to find people at the moment. And also the next availability of electric power, we call grid congestion. I don't know whether that's a problem in other countries as well, but in Holland it's quite a big issue. There's just not enough electric power to supply to new housing project, for example, to provide to new companies starting up in the city. And also Schiphol Airport has some problems here, and they had to withdraw some of the substitution plans to 2027 or 2028, and then only then they can go on substituting. Yes, I would like to make a final statement on a questionnaire that we organized. When you click one further, please. We have organized a questionnaire among our colleagues, among European labor authorities in the EU member states. What we see is that, well, one very general conclusion is that we see not many European countries do the same yet, but Norway and Denmark are quite active as well, as we know. Maybe we don't know anything, so we'd be delighted to hear experiences of other countries as well. At least we know about Norway and Denmark, that they're relatively active in the field as well. Let's see, it's now, okay, almost 5 o'clock. We started a little later, so I can tell you a little bit about this. Yes, you can move on to the next, please. I just promised to tell you a little bit about the professional exposure limits for nanoparticles that have been developed quite some years ago, I think more than 10 years ago already. It's developed by RVM and others, and it's not really health-based, but it's more like a precautionary, pragmatic benchmark levels that we use. And depending on the chemistry, it's 20,000 to 40,000 particles. Myself, I think that looking at the specific composition of aircraft engine emissions and the ultrafine particles found there, and also diesel engine emissions and the carcinogenic substances found in these emissions, maybe even lower recommendations might be needed for that specific class of UFP particles. Well, there's a reference to the report. I think this one is in Dutch, unfortunately, but there is an English summary in any case. Well, then just one very last slide, just for your information. I just wanted to show you that because in the Netherlands, also in the construction industry, it's quite a big issue that emission-free, that's housing projects and other building projects have to be emission-free more and more. Not particularly because of workers' health, but more in connection to environmental goals, CO2 and also nitrogen deposition. But there's quite some innovation going on, and there's more and more use of very large battery packs on construction sites, used to charge electric equipment, electric excavators, for example. Another example that we see more and more is that electric equipment is equipped with multiple batteries that can be interchanged. So it's quite interesting to see a lot of innovation going on over the last couple of years. So that's one maybe little optimistic last statement to finalize my presentation. And I think I saw some questions coming in the comments.
Yes, indeed, Jeroen. There are some questions. Well, I can read aloud so that everyone can hear it. And the one question is from Ties Korstanje, and she is saying that in the context of substitution in Denmark, some tests have been performed with mixing SAF into the jet fuel. This lead up to a considerable degrees of APF emission. What is your opinion about this?
Oh yes, that's we haven't told that. Yeah, we have seen those project in Holland as well. And, there's partly they partly use well, not really biodiesel, but biodiesel like not substitutes, but also part of the fuel can be replaced, or I think not complete part of the fuel yet, but I know of trials going on in Holland as well, and it gives also indeed a reduction, and any reduction that can be achieved, of course, is welcome. And I think we will need practically everything that we can do. It will be additional to other measures, of course. Almost, I think. I don't think it should be the only measure taken, because the reduction will be, because we need more reductions of exposure. And what I have not told you so far in this respect is that all the plans that Schiphol Airport and others have now, and that will be implemented towards the year 2030, they have some very rough estimates of the reduction of exposure that can be achieved by that. And what we see now, that at max it would be, well, maybe around 20% reduction, which is not really what we hoped for beforehand, but it illustrates that probably we need everything we can do to achieve as much reduction as possible. So.
Okay, and then we have another comment or question from James Beachay from, I think it's from United Kingdom. And then the question is, or comment is that it would be interesting to compare operator exposures with airports which have more electrification vehicles and without. So then to see how the impacts of the controls are. So I don't know if you have something to say about this, Jeroen.
Yeah, that will be interesting. I think that will be something for the future. I think, because we are quite well. We Dutch airports are working hard now, but there's even now still at the beginning of implementing all measures. And I can say that Schiphol Amsterdam has moved quite far in substituting diesel-powered engines now, but not quite as far now in implementing measures aiming at aircraft engine emissions. We're really at the start, and maybe in Denmark, Copenhagen, they're a little further. So it may be interesting in the near future, I think, when airports are moving ahead in some of the countries to make comparable studies. And always a question who will initiate studies and who will pay for the studies, but it will certainly be interesting, I think. So there are more questions. I see a large comment. I see some information from others. Thank you for that. Yeah, I see some remarks on the airlines and on also some other remarks about cooperation that's needed, and because of the many subcontractors, etc. That is certainly a point that we of my colleagues saw. And in fact, they also pressed all parties on in and around Schiphol to try and start cooperations, because in the very first start of inspections and on the very first start of the issue in 21, we saw that some companies attempted to point at each other to try that they were not responsible for this and they were not responsible for that. So it's, I think, important when you are an inspection operating at airports to try and press all companies active on airports to start cooperating. But it's clearly needed.
Okay, then there's another question from Pete Espinel about, are you aware of any studies undertaken that include personal sampling on workers? I'm not sure what he's trying to say here, but...
Well, maybe you were a little bit later, but I've just told about one study in Holland that in fact did personal sampling on workers. That was the University Utrecht and NCAL study. And it's quite an extensive study. It can be I've put a reference in the presentation, so you can look up the report. Although I think the report itself is in Dutch, but there's also a presentation which is more extensive. As I said, on the Epicode 25, there was a presentation on this study, which is somewhat more elaborate than I could have been telling today. And also at the Iowa 24, there's been a more elaborate presentation. But well, at least in our country, there's been one quite extensive study in which personal sampling was performed.
Okay, then a question from Paolo from Italy about the other chemical compounds which are carcinogenic. And he's mentioning benzene, formaldehyde, or butadiene.
Yes. Well, there is.
What about them?
I've in the beginning of the presentation, I've told you about the investigation made by RIVM on the composition of aircraft emissions. And in the report, there's a very large table presenting all components found in aircraft engine emissions. And well, these are benzene, formaldehyde, BA, and butadiene were all found in aircraft engine emissions. And the full report can be found on the internet, and I've put a reference here on the slides as well. So there's much more information than I've told you today.
Okay, very good. Just to point out that this webinar is recorded, so you can, at the Spanish Occupational Hygiene website, you can have the link, so then you can see again this presentation. Well, some new questions are popping up. Let's say, give it the last one. And that's if technical measures are not yet sufficient implementable, which organizational measures can be advised at short term? Yeah, for short term, that's rather complicated. There are all kinds of trials going on, even much more than I told you today. Some including also, for example, totally different measure is to provide shelters to workers working in close proximity to airplanes. That's shelter just protecting workers to the direct jet blast coming out from the motor. And if workers don't have a direct task, they can go into the shelter or behind the shelter, which has it will have a little effect. Some workers are using personal protection equipment temporarily because it was not obliged by the employer, but they just wanted it themselves.
It's of course not the preferred option. We as occupational hygienists not always like this option, but well, it's quite complicated indeed to implement more successful technical measures. So in addition, this kind of measures are taken as well. And there's also there's another trial that has been done is trying to use air mist spray, water sprays, for example, to cut down particles. So there's more going on, but it's altogether it's quite a challenging problem to tackle.
Okay, thank you, Jeroen. And then with that also, I think Stefan's question is already been answered, because he was thinking about the PPE, if it would be also a good control measure at short-term, medium.
Yeah.
Just to point out, we have some comments from TNO, Geke van Meer, saying that TNO is conducting an in-depth study on the composition of OPF commissioned by the Schiphol, so that also will be very interested to see the results of that. And then, yeah, okay, last question, and then we will finish this. Is a question about the PPE again. What type of respirator would be suitable or better for these workers if they want to have or want to use RAP?
Yeah, what we see now, I think, or maybe others can confirm or not. It's the normal FFP2 or FFP3 particle respirators. Well, which is, I think, myself, quite of a burden to workers to use them for 8 hours per day. But okay, some of the workers just insisted on using them themselves because they were concerned. So it's relatively simple what they use. It's not but it's negative pressure. It's just the normal filtering pieces what they use.
Okay, so thank you very much, Jeroen. I would say with that, we will close this webinar. And again, I apologize for the start of this webinar. We had some technical issues, but yeah, that can happen. And just to mention again, we have recorded this webinar. It will be made available. Just go to the Spanish occupational hygiene website, and then you can find a link. I think within 1 or 2 days. And with this, I would like to thank you all for assisting this webinar, and I probably will organize again in due time another webinar. And well, with that, I would say it was very interesting webinar, very interesting topic, which I see a lot of challenges still are coming up. And with this, I would thank you all for your for being here, and hopefully it was useful, and maybe we will see each other next time. Thank you very much, and I will say goodbye to all of you. Bye-bye.
Thank you all.